Okay, for this first example, I've got the y equals 2 times the cotangent of 4 times the quantity of x plus pi over 2. What's nice about this example is my argument is already factored. Remember, you have to have the factored form of the argument to make our formulas work out nicely. I also have on the board 1 period of the cotangent, the regular cotangent of x. Okay, and remember that the vertical asymptotes are at 0 and pi, with the x-intercept halfway in between at pi over 2. And then remember the amplitude idea is the height of the point halfway between the asymptote and the intercept, which would in this case be pi over 4 and 3 pi over 4. And with an amplitude of 1, the height of the graph is 1 and -1 at those two locations respectively. Okay, so now I want to find our 5 key points. I got to find our amplitude, vertical shift, phase shift, period, and then the 5 key point, and a reflection if there is one. Okay, so we've got to go through all that with this new graph and then plot the graph. So the first thing I see working from the outside is that we have an amplitude of 2 and a vertical shift of 0. There's nothing being added or subtracted to this. So I'm going to write those down. The vertical shift is 0, and the amplitude is also, oh no, it's not 0, it's 2. And the reflection, well, remember, because this constant multiplier on the outside coefficient is positive, we won't have a reflection. So none. Okay? So no reflection. If there were a reflection, we would just plot the graph increasing rather than decreasing. Okay, so it just flips the graph over. Kind of imagine flipping that around the x-axis. Okay, so there's no reflection here. Now we look at the phase shift and the period. Okay, well, the phase shift, again, when this is in factored form, the phase shift is always what's being subtracted from the x. Well, if I have a plus here, it's really the same as x minus -pi over 2, and so what's being subtracted is a -pi over 2. Remember, it's going to be the opposite of the sign that's in the argument. So the phase shift is a -pi over 2, or you could say left pi over 2, right? You're going to be shifting everything to the left. The period is going to be, remember, for both the tangent and the cotangent, it's pi over b, which in our case is pi over 4. Okay, so it's going to be a left shift of pi over 2, and then a period of pi over 4. So now I need my 5 key points. Okay, so the 5 key points. Well, the phase shift gives us our first point. Remember, if I'm starting this from 0 to pi, from 0 to pi, the phase shift gives me my first starting point. So I'm going to shift that initial point left pi over 2. So we're going to start this graph at pi over 2. And then I need a pi over 4 period. Okay, so pi over 4 period means I add pi over 4 to this point. Well, I guess, yeah, I could add pi over 4 to that point to get the last point. Or what I usually do is I cut the period into quarters. I take pi over 4 and multiply by another quarter, right? And that will give me the increase, what I need to add to each point to get the next key point. That would be a pi over 16. So what I need to do is start at -pi over 2 and then add pi over 16 to get the next points. All right, so let's do that. We'll start then at -pi over 2. We're going to then add pi over 16. Now I need an LCD. Well, pi over 2, or half a pi, is the same as 8/16, right? If I build up the denominator. So this will be -8/16 plus, oh, what am I doing? Put the pi on the bottom, I wrote that wrong, very much wrong. Okay, let's see, so that'll be negative 8 pi over 16 plus pi over 16, right? So negative 1/2 is the same as negative 8/16. When I add those, I get negative 7 pi over 16. So that would be my next point. Negative 7 pi over 16. Then I start at negative 7 pi over 16 and add another pi over 16. That will give me a negative 6 pi over 16. And if I reduce that, it would be negative 3 pi over 8. So that'd be my next point, is negative 3 pi over 8. Then we're going to add another pi over 16, but I'm going to go to the unreduced form so that I don't have to make it build these up for an LCD again. So I'm going to go to the negative 6 pi over 16 and add another pi over 16. That will be a negative 5 pi over 16, which doesn't reduce. And then I'm going to take that negative 5 pi over 16 and add another pi over 16. Do this off to the side here. Negative pi over 16 plus pi over 16. Well, that would be a negative 4 pi over 16. And of course, that reduces to a negative pi over 4, which is my last point. And now consider that the gap from the left end to the right end, negative 1/2 to negative 1/4, is just a quarter of a pi, right? Half to a quarter is a quarter. And so that period should be a pi over 4, quarter of a pi. Okay, so that should match up. Okay, and as I'm looking at this, I'm thinking about my fractions. If you imagine for a moment the pi's not being on there, you've got 1/4, 5/16, 3/8, 7/16, and 1/2 going to the left. So if you go a quarter to a half, that distance from a quarter to a half is the same distance as you would have from the quarter to the y-axis. Okay, so think about it. This is like if you think about it like a ruler, right? If you have your inches, you've got your half inches and quarter inches and eighths inches and sixteenths. Those of you who measure things. So I picture this like I would the inch markings or the fractional inch markings on a ruler or tape measure. I like the 2, 4, 6, 8 or 2, 4, 8, 16 on the bottom there. Okay, so now that I know that, I want to sketch out my axes. Okay, so my y-axis, I'll keep my y-axis over to the right because I know most of this graph is going to be on the left with all these negative values. In fact, the whole thing is going to be to the left. Okay, so that gives me an x-y axis. And then I know that for the cotangent, the left and right endpoints are going to be my vertical asymptotes. So I'm going to put maybe my negative pi over 2 way out there on the left. My negative pi over 4 is half the distance from the y-axis to negative pi over 2. So there's negative pi over 4. So my whole period is going to be between those two marks. I'm going to go ahead and make that those two my vertical asymptotes. Okay. And then what's nice about that is that I'm going to have another vertical asymptote on the origin, and every pi over 4 multiple, I guess, going out. Okay, so now I know that my middle point on the cotangent is going to be an x-intercept, and that's going to be at negative 3 pi over 8. Okay, and because I don't have a reflection, I know my graph is going to be decreasing over that interval. The main things I need yet are the amplitude and the other two key points, which are my 16ths here. So I have a negative 7 pi over 16 and a negative 5 pi over 16. and I need to get an amplitude of 2, so I need to go a height of 2 here. So I'll make that 1 and then 2, and then we'll go -1 and -2. And so up here at 2, if I follow that across, get a point. It's pretty close. I'm roughly sketching these in. And then at -2, I bring that across and down right about there. Okay. And then, wow, I need this. This could be a very narrow, very tall looking graph because that period is so short. But that's okay. Still need to make it, it's not linear. It still has to have that curve in the middle. So I'm going to curve that thing up toward the asymptote. And then this one is going to curve down toward the asymptote. So it's not a real exaggerated curve, but hopefully you can see how that kind of bends in the middle there and then shoots off toward the asymptotes. Okay. Okay, that should give me all the information I need. I've got my vertical asymptotes, I've got my x-intercept, and I've got my amplitude at the other 2 key points. If I needed to extend this another period, I could always extend my my tick marks over to the right and put another period over there. It would come down at what's this? pi/8, -pi/8 would be the halfway point, and it would kind of go up that way and come down that way, have the same amplitude as the other side. I probably didn't draw that quite accurately, but you get the idea. It's going to be the same shape. Okay. So that gives you an idea how to sketch the cotangent. Again, remember the difference between the cotangent and the tangent. There's really 2 main ones, the way that we plot them out. The cotangent is always going to be decreasing, whereas the tangent is increasing, unless there's a reflection. If there's a reflection, then it's the other way around. And then with the cotangent, we start our period at 0 and go over to pi and shift from 0 on the left. Whereas with the tangent, remember we go from -pi/2 to pi/2 and we shift from the middle point, which is where the x-intercept was at the origin. Okay, so the shifts start from the middle and go over, and then you back off for the period, back off one side and go forward on the other. Whereas with the cotangent, you shift from the left end and just add your quarter period on after that to get your 5 key points. All right, so those are the main differences between them. The cotangent, because it starts at 0, those shifts and periods, the phase shift and period are going to behave a little bit more similar to the sine and cosine, except you're going 1 pi for the period rather than 2. All right, the tangent's quite a bit different because it straddles the y-axis and goes from -pi/2 to pi/2. So it's going to be the one exception to the rule with the phase shift and the period, where it doesn't start at the origin, it straddles the origin. Everything else pretty much starts right on the y-axis there. Okay. The next thing we'll study will be the graphs of the secant and cosecant. And what you're going to find is some very interesting features of the graph. You're going to have more vertical asymptotes, and we're going to talk about the idea that they're reciprocals of the cosine and sine respectively.